Hello guys, it's Boost Knowledge again, and as you can see, we are updating more and more frequently like we do it at the weekends because we want to get all the syllabus, the humanities, the sciences and math and English getting running up. And we also like doing it really quickly. So we are back to a subject we haven't done for like a month, mathematics. Last time we did a very fun problem, which was, well, the broken calculator one. I hope you learned a lot from it and enjoyed it. Of course, it got about 60 views, which I feel very happy about. And now we're going through the Edsel K3 CGP syllabus, which is this useful book where we get nearly all our information from. This lesson is about how to calculate the gradient in a straight line. So what you may ask before we even begin is, what is a gradient? So a gradient is how steep a line is. So like you can add really steep lines, and I'm going to draw it here. Wait a sec. Is like if we take this black line, this line is definitely very steep. It's more steeper than this line, which is more steeper than this line. And of course you can add negative ones. And let me get rid of all these lines. A second point to add is that how steep is also the line that rises the quickest, which is the highest gradient. That's an easier way to remember this if you don't know what the word steep means. And if a line slopes down, it has a negative gradient. Negative, if of course, about that example when the line was sloping down, yes. And finally, to add, if a line is completely 0 degrees straight, it has a gradient of 0. That's easy to see because, well, it's completely straight. So let's move on to our next point, method on solving gradients. So how can you solve gradients? So there are two methods. The first one is the easy one. The easy one is like when you get a graph. We'll look at some examples later. The gradient equals how much the line goes up when going across by 1. So now let's move on to the second page. Oops, sorry. And here we look at the first page, and here I am writing. So look at this point is 0. This point is 0, 0. Oops, why is it not corresponding? This point, as you can see, is 0, 0. And this is 1, as you can see. And if you move to the right, and then you go up. And actually, I'm going to make it bigger, actually. And look at the top right corner. Yes, of course. This is 0, 0. This is 0, this is 2. So the middle point, which is somewhere like here, is 1. And if you go up to here, and you have to go up like this. This is 2 points on the line. You know that this is 1, because 1 minus 0 is 1. And sorry, wait a sec. That's 1. But how much do you go up? It's actually 0.5. It's actually 0.5. So the gradient of this of this question is 0.5. That's easy enough. But you know it's 0.5. How can you make sure it's 0.5? And let's scroll back to this and back to the first page. This was the easy method. The gradient equals how much the line goes up when going across by 1. But the second one is called the useful one, is that the gradient equals, the gradient is actually the change in y divided by the change in x. What is that? So if we go back to the question and now we zoom in on the second one. Wait a sec. The second one, look to your right. You can see that this green line has a positive gradient. And here, let me get back to this again. If now we know that this is 2. Wait a sec. This is 2. We move from 0, 0. This is 2, 2. We move to the right by 2. Then we go up by 2. 2 divided by 2 equals 1. So gradient of this is then 1. And this method is very good if you have only specific points where you know what the value is, like the last one. And I'm going to put this to the right. We don't even know that this point is 1 or this part is 0.5. We actually don't know. So it's only guesswork, and it's not really 100% accurate, especially when you're doing harder questions. And note, because we will be doing physics in this part too, because we will be studying physics here, so a useful method. Wait, sorry, I need to make it bigger. In physics, the equation. Sorry, I can type. In a velocity time graph, to find the acceleration, and we will talk about later, is delta. I don't know why it's this symbol. Let's change this font. Okay, delta x, delta y divided by delta x. Don't know why. And that is a, the acceleration. And you just have to note that down for now. It's not really 100% important for now, but you can see that physics and math in this aspect is linked together. Moving on to the next page. I know we're back to this page again. What we need to do is continue finding the gradient, and we are going to focus on the bottom two ones. So sorry for, let's do some, this is actually practice. So this one, the last one will be, this is 4, as you can see, this is 4. So coordinates -2, 4, and let's get this 0.00. This is -2, 4, and you can draw this out. The good thing is to draw it by dotted lines, but I don't care. So the change, the delta of y should be 4 to 0. The delta of x is interesting because it's 2, and sorry, it's -4. Delta y is -4. If you go 0 minus 4, sorry. Delta of x is interesting because it's 2 to 0, and that's not the problem because you use -2 minus 0. And that works, which is negative 2. Oh, sorry, we get 2. Sorry, it's not negative. Mistake, sorry. We get 2. And then you know negative 4 divided by 2, and then the gradient is 2. Get it? The last one is for you to do as, well, kind of homework, and you can do it by yourself and like do this in the comments and stuff, because yeah, there's not much time left in the lesson and we still have a big point to cover. Now to page 3. The thing that most examiners do in GCSE, they don't just give you a graph. That's too simple. They get nasty, and what they do is say, when they don't give you the graph, they say, what is the, for example, they say, what is the like gradient in a graph where x, so the point A, where like it's point A and B are parts of the line, and you could do A equals, for example, 0, 0, B is like 1, 2, for example. And this thing is very bad because you can't visualize it directly. But the good thing is, using the equation, and we have that equation here, the change in y divided by the change in x. And that's very useful because that is how we do it. Change in y, you always use the second to subtract the first. That's very important. And I'm putting stars for this. Okay, it didn't change the character. That's good. Using the second to subtract the first. So it's the change delta. I just write delta y. Don't write this. Delta y equals 2, because 2 minus 0 is 2. Delta x equals 1. 2 divided by 1 equals 2. Gradient equals 2. And that's great. You outwitted the examiner. Not actually outwitted, but you solved the examiner's question, and you can get marks for this, which is, well, good. Tips. Oops. I'm really sorry about this. And finally, we go to top tips. And these are important. You have to remember them. Firstly, lines go from left to right. That is the first thing you have to remember, because if you think that all lines are going from right to left, the second value, subtracting the first value, we did it like here. You can't use that. You have to use the first to subtract the second. But most textbooks say the second to subtract the first. Oh, this is very confusing. So all lines go from left to right. That's the thing. And the second thing from this is that you always subtract the left from the right, or it's right minus left for x and y values. And the most important thing is y divided by delta x, not the other way around, which is crucial, or you'll get no marks for the question. So I think that's all you need to know for, well, calculating the gradient. I hope you learned a lot. The notes in the TXT document will be also sent to you. I hope you learned a lot in this lesson. Thanks for watching, and I'll see you next time. Bye.